Okay, so here we are, another set of questions, another opportunity to, learn something new, figure out a piece of the puzzle that may be missing. This is the Chapter 9 Study Team Test. This is the test given in 2016, which is a lot like the version I used in 2015. I think just a couple questions were added and a couple questions were tweaked. So let's start with question 1. There's 2 problems. Again, solve a system of equations, and you can use pretty much any technique you'd like. I'm going to begin with part A, and as we look at part A closely here, the thing I'm noticing right away is obviously there's a lot of ways we could approach this. One of the things we could do, this is a suggestion, is I could take through and multiply this second equation through by 5. If I did that, you'll notice that my y's would be, I'd have a negative 5y and a positive 5y. After I distribute this 5. Remember, it would have to hit every single term on both sides. And remember, terms are those things separated by plus or minus. So on the left-hand side, there are 2 terms. One of the terms is 6x, and the other term is y. And on the right-hand side, there's a single term, just 8. So both the 6x would be multiplied by 5 and the y, and that would give me a negative 5y. So that's one way I could do it, and when I added them, added equal things to equal things, I would get equal things. My y variable would eliminate, and that's the elimination method. But I'm going to choose to use substitution instead this time around. And what I'm going to do is I'm going to take this first equation and I'm going to isolate y by subtracting 6x from each side. So when I do that, this second equation becomes y equals negative 6 times x plus 8. The reason why I chose to do that is now this is a perfect substitution for y in the first equation, right? And I'm going to do that now. I'm going to replace y in the first equation with this blue highlighted thing that's equivalent to y from the second equation. When I do that, let's rewrite that first equation. It's a negative 8x and then minus 5. And then instead of writing y, I'm going to write this thing that's equivalent to y. I'm going to write negative 6x and then plus 8. And then on the other side, that will equal the number 26. So there we go. I've done, that's my substitution. Now it's just a matter of solving this equation for x. I'm going to use the distributive property to get rid of the set of parentheses on the left-hand side. So that would make this a negative 8x. It would become plus 30x, and then minus 40 equals 26. So notice how I did distribute this negative 5 to both the 6x and or negative 6x and the positive 8. Combining like terms now, we have this should be a positive 22x minus 40 equals 26. And if I add 40 to each side, we can see that negative 22x would equal for positive 66. So if I choose to divide both sides by 22, that would be a wise thing to do. On the right-hand side, left-hand side rather, you can see I made a giant 1. 22 over 22 is equal to 1. And 66 divided by 22 is the number 3. So x is equal to 3. There we go. Please notice as I'm doing this, right, these are factors. It's 22 times x over 22. So that's where I can make the giant ones. On the last test, this is kind of an aside. Let me move over here and show. One of the things that happened was I think there was a problem that had an x plus 3 over 3. Notice the top, the things in my numerator there are not factors. They are terms, and we can't cancel common factors. It's bizarre anyways. In fact, just as a quick example, if you were to consider, let's do 8 plus 2 over 2. If you thought that you could cancel out common terms, you would get an answer of 8. And this is not 8 at all, right? That numerator is the number 10, and 10 divided by 2 is the number 5. 5 is not 8. So I'm even reluctant to do this, but do not do this, right? Do not do that. Those are not common. These are not. This does not make a giant 1, right? It's a bad day. Now you can do this. You can divide each of them individually by 2. You could do that. So you could look at, for example, 8 divided by 2 plus 2 divided by 2. And you can see 8 divided by 2 is 4, and 4 plus 1 is indeed the number 5. But if you just think that you can cancel out common terms, no, that's not a good thing. However, I'll go back to what we can do. We can cancel out common factors. And again, the problem with mathematics is a lot of times we'll look at things, we're pattern recognizers. We see what we think is a pattern here and we latch on to that, and we misapply the pattern. This is completely legitimate. We can look at it 2 ways. If I don't write the giant one first, notice this does become 16 over 2, which is indeed 8. And if I do eliminate the giant one, it's also 8. So let's come back to our problem. We know what x is. X is 3. It turns out we have a great way of figuring out what y is. We wrote it right there, and it's highlighted in blue. We know that y's are equal to negative 6 times x, and we know x is now 3, and then plus 8. Y would equal, let's see, 3 times 6 is 18, so this is negative 18 plus 8, and then y would be the number negative 10. So my solution is the point 3 comma negative 10. So when x is 3, y is negative 10, and that works for both of those points. And it's very wise to grab your calculator and just quickly practice plugging in those values for x, y, and ensuring that in the first case that when you plug them into the left hand side in the first equation that you do indeed get 26, and in the second case you better get the positive 8 there. And if you do, then this is a solution we can live with. If you don't, come see me, and if you can convince me that my answer is wrong, you probably get some extra credit. On this next problem, caused some interesting things to happen here. I'm going to go ahead and use the elimination method, and I am going to multiply through this second equation by the number 2. And the reason why I'm selecting 2 is then this will give me a positive 18y and a negative 18y. Those will become opposites of each other. So let's rewrite this equation. It's going to become negative 4x minus 18y equals the number 22. And I'll go ahead and rewrite the first equation up there. It was a positive 4x plus 18y equals negative 25. So here's the thing that I think a lot of you immediately saw. Hey, look at my x's are opposites, right? So when I add them, I'm going to get 0. But also, what? My y's are opposites. Although, Mr. Roberts, you didn't write the y there. It belongs. Well, when this happens, right, what becomes of the left-hand side? This left-hand side, negative 4x and 4x is 0. Negative 18y and 18y is 0. So I end up with a 0. On the other side, I end up with the number negative 3. This is clearly false. False. So, or we say it's a contradiction, right? 0 is not negative 3. So what's going on here? Well, if you were to look at these equations, right, it turns out that they are parallel lines with different y-intercepts. And in that case, there are no points that they share in common. And I have no idea what the slopes look like or what the y-intercepts is, but just visually what's going on is we've got 2 parallel lines, and when we solve a system we're asking where do these lines meet, and the answer is here. They don't meet. Why? Because they're parallel, parallelion, together beside one another. They never intersect. So that's one thing that can happen. Another thing that could happen, so on this one we would just say no solution. Another thing that is possible is it could be the case that you've got a line and then you've got the line again, right? You've got the same line twice. And when that happens, any xy ordered pair that works in one line would also work on the other. And so in that case, there's many solutions. There are many xy pairs that work in both. But for this one, because they're parallel and they don't have the same y-intercept, there's no solution at all.